This is 5.1, and this is the first major shift in the class. So we are no longer talking about a big set of data points where you would copy and paste a table of data into a spreadsheet and find things like the mean, the median, the mode, the interquartile range, outliers, all that kind of stuff. We're no longer dealing with a complete list of data. We're now talking about probability distributions. And so we're going to start by talking about discrete probability distributions. These are, once again, discrete numbers are numbers like 1, 2, 3, 4. Sometimes they're called the counting numbers or the natural numbers because it's numbers you would use to count things in nature, right? Like 1 sheep, 2 sheep, 3 sheep. That's how we use those numbers. In the next module, in module 6, we'll talk about continuous probability distribution. So module 5 is discrete. And then when we get to module 6, we'll talk about continuous probability distributions. Again, continuous can take on any value in between those discrete numbers. X is the value, the outcome of the probability distribution. P of X is the probability corresponding to that X value. And then here are formulas for the mean, the variance, and the standard deviation. Here's our first example. And what we did is we went back and we looked at the 2010 US Census, where they come around and they knock on your door and they say, how many people live in this house? And people say 1 person or 2 person, 3 people. And so these are the values, 1, 2, 3, 4, 5, 6, 7 or more. Okay, those are the specific values, the specific outcomes of this example. And then below them are the corresponding probabilities for each outcome. Now, this is not theoretical. This is empirical. It's based on experiment, going out and collecting the data. But notice there is no raw data here. There is not a list of 1s, 2s, 3s, and 4s, right? We're giving you the information as a probability distribution for all of the outcomes. Based on our empirical evidence, what is the probability that there would be 1 person in the household? 26.7%. What's the probability that there would be 4 people in the household? 13.7%, right? This is a probability distribution. And here's how we could make a histogram of that probability distribution. So notice the vertical axis, the y-axis, is the probability. And then each one of these bars represents the corresponding distribution. So this value right here is 26.7, and this is 33.6, and so on, okay? So again, it's not the raw data, it's the data summarized as a probability distribution. My next question is, what's the average? What is the average household? How would we figure this out? We can't take the raw data and put it into a spreadsheet and have it give us the average. So how do we find the average out of this? And if you think about it, it's almost like a weighted distribution. We're going to take each value, and we're going to multiply it by its probability. So we're going to take the number 2 and multiply it by its weighted probability. The number 3, multiply it by its weighted probability. And then we're going to add them all up. And that will give us the mean. That will give us the average of the probability distribution. And that's exactly what we do right here. So if you take the value 1 and its probability as a decimal and multiply those together, you get this. And then you do the same thing for every outcome. 2 times 0.336 gives you this. 3 times 0.158 gives you this, and this, and this, and this, and this. And then you add up all the green values. And when you get done adding them all up, that is the mean or the expected value. Based on this probability distribution, we'd expect the average household to have 2.525 people. So we have the mean. This is fantastic. We showed you a method for calculating the mean. And if you go back up to the formulas that we talked about earlier, that's exactly what this formula says to do. Notice it says take the product of the value and its probability for each outcome, and then add them all up. And that's what we did. So it's sort of like decoding this formula, okay? So we've taken care of the mean. We've got that. What about variance and standard deviation? Again, looking at this data set, we found the mean, and the mean was about 2.5, which is, I don't know, in here someplace. What's the standard deviation? How would we find that? And so let's go through the process of calculating the standard deviation. And here's a table that may look a little bit familiar. Remember way back in the day when we did the actual calculation of a standard deviation with the data set? Remember how we took all of the values and we found the mean, and then we found the difference from the mean, and then we squared the difference from the mean? Remember all that? We're going to do the same thing again. So once again, just to orient you as to what we're doing, here is the outcome, the value, and its probability. The outcome and its probability. Outcome, probability, outcome, probability, outcome, probability. And when we multiply these two things together, we get this, and we add these all up to get the mean. So here is the mean. This is the mean. Fantastic. And that's the calculation that we just did earlier. Now, for each value, the number one, we are going to find the difference from the mean. This is the difference from the mean. So we are going to take, in this case, 1 minus 2.525. And that value goes right here. So that's the value, subtract the mean. So we take 1 minus the mean, 2 minus the mean, 3 minus the mean, 4 minus the mean, 5, 6, 7. So now we found for each value the difference from the mean. Then we squared the difference from the mean. And then, and here's the new wrinkle, because we're dealing with probabilities, you now take the probability of each event, this probability, and you multiply it by the square of the difference from the mean. And this gives you what you could sort of think of as the residual. Remember, we talked about this earlier when we were talking about standard deviations with data sets. This is sort of like the residual. And now you add these all up. And that is the variance. So this is your variance. And once you have the variance, all you have to do is square root it. So you just square root that variance, and that will give you your standard deviation. So we've taken a probability distribution. We found the mean, the variance, and the standard deviation using techniques that we've explored earlier. Let's take a look at one application of this. So what is one way that you could apply the mean? This is an example called expected value. So if you are playing a lottery game, you might want to know, over the long run, are you expected to make money or are you expected to lose money? What is the average over the long run expected value of this game that we're going to play? Okay, and so let's go through this example really quick. Let's say that West Shore Student Senate decides to raise some money, and so they're going to put on a lottery, and it's called the Pick 3. And so here's how you play. You pay $1, so you pay $1 to play, and then you get to pick a 3-digit number. And if you match all 3 digits in a specific order, you win $500. Good job. So what's the expected value? If you played this every day for the course of 2 years, what would be your expected value over the long run? So we're going to break this into 2 outcomes. Outcome number 1 is you win. And if you win, the value of that outcome is $499 because you won $500, but you had to pay $1 to play. If you lose, the value of that outcome is negative $1 because you paid $1 to play. So now we have our values. We have our values, $499 and negative $1. Okay, if you win, it's $499. If you lose, it's negative $1. Now we need to calculate our probabilities. So the probability of you winning is you have a 1 in 10 chance of matching the first number, a 1 in 10 chance of matching the second number, and a 1 in 10 chance of matching the third number. So your probability of winning is 0.1%. Your probability of losing is the complement of that. So 99.9%. So now we have for each outcome a value and a probability. We have a probability distribution. And so if you win, here is the value that you would win, and here's the probability of that happening. We multiply these two things together to get the expected value of winning. We then also find the values for losing. So if you lose, the amount would be -$1, and the probability of that happening would be 0.999. And so the expected value of you losing is this number. And what you do is you add these together. Once you add them together, that will give you the mean. This is the average. And you can notice that this mean is -50 cents. So on average, over the long run, you are going to end up losing 50 cents every time you play. If you end up playing this game and you add these together and you end up with a positive value, that's good. That means that you're going to make money. If you add these together and you get a negative number, that's bad. That means you're going to lose money. And if you add these together and you get 0, that is a fair game. That means you're neither going to make money or you're going to lose money. It means that overall you're going to break even. And so those are sort of the 3 outcomes that you can have. So this is an unfair game. It's tilted such that you're going to lose 50 cents on average every time that you play. And so it's not considered a fair game. So let's take a look at the spreadsheet that we have. And so the first thing we want to do is we're just going to follow the recipe up at the top. The headers in each column guide us as to what we're supposed to do. So we're going to take P of X and we're going to multiply it by the value. So take each value, multiply it by its probability. There we go. So 3 times 0.15 is 0.45, 4 times 0.25 is 1, 8 times 0.3 is 2.4, and 11 times 0.3 is 3.3. And then we are going to add them all up. And there is the mean, 7.15. So in this situation, I have 4 outcomes. I could get a 3, a 4, an 8, or an 11. I don't know what game this is, but these are the numbers that I could get. And then here are the corresponding probabilities for each of those outcomes. This is a probability distribution, right? There are 4 outcomes and each one has a different probability. I multiply each outcome, each value by its probability, and then add them up, and that is the average. So my average would be 7.15. Now I'm going to take each value, and subtract it from the mean. And I'm going to put some $signs on the C6. So that way, when I fill it down, it doesn't shift, right? It stays frozen. And so here's the difference from the mean of each of the values. So 11 is 3.85 above the mean. 8 is 0.85 above the mean. Okay. 4 is -3.15 below the mean. All right. So this is my difference from the mean. I'm going to square the difference from the mean. So we'll take that to the 2nd power. We'll fill this down. And now here's the new wrinkle. This is the new thing that we're doing because we're dealing with probability distributions. I need to take this value, this difference from the mean squared, and multiply it by the corresponding probability, the probability for that outcome. And so I do this for each one. Add these all up, and that is the variance. And then once you've got the variance, you know the next step is pretty simple. You square root the variance. And here's your standard deviation. So that's how you build the spreadsheet for 5.1. So now you can change these input values and everything will automatically change for you. So problem number 3 asks for the mean and the standard deviation. So now that I've built this, I'll clear out these values. Let's put in a 2, a 6, a 9, and a 12. And the probability of the 2 is 20%, 0.2. The probability of getting a 6 is 5%, 0.05. The probability of getting a 9 is 0.25, 25%. And the probability of the 12 is 50%. So I just drop in my values and their probabilities, and everything is automatically calculated from there. And so you can see my mean is 8.95. So I'm going to copy and paste that value here. And then all of the other calculations automatically adjust. And so here's my variance. I don't really need that. I just need the standard deviation. So here's my standard deviation. I'll copy and paste that in. I need to round these to 2 decimals. So there's my rounding, and I'll hit submit. And there we go.